Hello guys, let's solve cousins in binary tree today. So this is again another question that's pretty frequently asked on TikTok. Uh, and I'm going to show a solution that's like the most intuitive and the most straightforward with like minimal recursive calls. A solution that would probably strike you if you actually see this in an OA or a interview. So let's see what the question says. So we are given the root of a binary tree with all unique values and the values of two different nodes in the tree x and y. So we basically need to return true if the nodes x and y are cousins. If not, we need to say false. So two nodes are said to be cousins if they are in the same depth but with different parents. So let's see a few examples. So this is a binary tree that we have, and we are given x is 4 and y is 3. So we see that they're clearly not in the same level, so they cannot be cousins for sure. So we return false. And in this example, we have this tree and x is 5 and y is 4. So clearly they are at the same level and they belong to different parents, right? So we return true. And in the last example, in this tree, we have x is 2 and y is 3. So which means that they are in the same level, but they have the same parent, which means that they are siblings and not cousins. So we need to return false. So let's see how to solve this problem. So we have the same example here. So let's see how to solve this. So we're going to use basic DFS to solve this problem. And um, while recursing, we're also going to keep track of two values. One, the level of the node, and two, the parent of the current node. So let's say we start at the root. So let's assume the level of the root is 0, which means we have 0 here, and the parent of the root, let's give it a value -1. We know that -1 does not will not be part of the tree, as we know as it's given that the values are between 2 to 100, right? So this is also called pre-order traversal, where you process the current node first and then you try to go left, and then finally you try to go right? So now let's first try to go left. So we have D, and then the level is going to be incremented by 1. So it's going to take 1 and the parent pass is going to be 1. And then you try to go left, it's null, and then you're done with the left part, then you go right, and you're going to get the level is going to be 2 and the parent is going to be 2. So now you're done with the left part of the subtree. Then you finally go to the right part of the subtree. So here you're going to get D of the level is going to be 1, the parent is going to be 1 again. And you try to go left, it's null. You go back, you go right, and then D is going to be 2 and the parent is going to be 3. So once you complete this, uh, once you complete processing the entire tree, we have this information that we can store. So this information is going to give you for each node what is the current level it is at, and also what is the parent of that node. So let's say we have x equals 4 and y equals 5. So we can store this information, and basically we just need to check if 4 and 5 are at the same level, and we need to check that if the parent of 4 is different uh, compared to the parent of 5. So we are also given that all the values in the tree are unique, which makes things more easy for us. So if both of these conditions return true, that is the same level, and different parents, then we return true. Else, in all other cases, we return false. So now let's quickly see how to code this. Alright, so let's first define the two maps that I was talking about. One to store the level and one to store the map. Um, Now let's define the recursive function. So it's going to take the node, the current level, and the parent, right? So first let's just make sure the node is not null. So if you can say if node is not none, or you can just say if node, both should work. So let's first store the level information. So can basically say node level map of the current node is equal to level, and then we can say the node parent map of the current node is equal to the parent. So it is actually possible to use the entire node as a key in our dictionary. So a node is defined this way, where it has three attributes: the val, the left, and the right. Uh, but we know that all these values are unique. Uh, so just to make things simple, let's just directly use the integer value as the key for this map, right? So now we're done processing node. So now let's recurse left. So we go left, we pass the left node, and then the level increases by 1, and then you need to pass the parent. So the parent of the left child is going to be the node itself. So you pass the node, and then you recurse right. Let's just copy this. You go right, uh, the level again increases by 1, and the parent is node itself. So just to reiterate, this sort of traversal is also called pre-order traversal, because you first process the current node, and then you go ahead, process the left subsection of the tree, and then finally the right subsection of the tree. Okay, so now we're done defining the recursive function, so let's just call it. So we're gonna kickstart the recursive call with root, and the level of root is going to be 0, and the parent of root is going to be -1. So once we finish, once this is recursive call completes, all the nodes have been processed, and we have all the information that we need in these two maps. So let's quickly just do the two checks. So the first check is going to be the level check. So we're going to check if they are part of the same level, and the second check is going to be the parent check. So we're going to check if they have different parents. So we don't want them to be siblings, rather we want them to be cousins. So if both these conditions are true, we're going to return true, else we're going to return false. So let's just quickly check it. Yep, it passes, and yeah, it seems to be reasonably fast. So there are, like I said, there are probably multiple methods to solve this problem, but I just wanted to show a solution that's most intuitive and most straightforward, and a solution that is probably going to strike you uh, if you actually face this question in an OA or an interview, right? All right, thanks for watching.